Assalamu alaikum. This is lecture 14 of Information and Communication Technologies, and in this lecture I am going to discuss about program development and the different ways in which you can write programs in computer languages. So here are the lecture contents. We will start with the brief description of program development approaches, and then we will discuss how a typical program works as described in program development life cycle. There are different programming languages which have been used by the programmers over the years to program computers. There are different components and tools available to program computer systems to solve the real world problems. So, as I have mentioned earlier, there are various approaches to program development, and one of the most commonly used approach is the procedural programming. Procedural programming is an approach to program design in which a program is separated into small modules that are called by the main program or another program or a module whenever it is needed. So it typically uses procedures such as functions, modules, subprograms, which are smaller sections of code that perform specific tasks. So procedural programming allows each procedure to be performed as many times as needed. Multiple copies of the code are not needed because you can call single function or subfunction repeatedly whenever it is required. So prior to these procedural programming, programs were one large set of instructions which often included some go-to statement which does not follow the procedural programming language paradigm. So that means you can go to one statement and then jump to another statement without following the sequence. So this form is the structured programming, which goes even further, breaking the program into small modules having a top-down design approach. So the components can be easily reused in procedural programming because we have small subprograms and modules, and they can be separated from each other. So this typical type deals with the aspect-oriented programming, which separates the functions so program components can be developed and modified individually from one another. So these are quite interlinked with each other. The another common approach is the object-oriented programming, often pronounced as OOP. So in the OOP, program consists of collection of objects that contain data and methods to be used with that data. And a typical element in the object-oriented programming is a class, which is a group of objects that share some common properties. Another element is the object or the instance, which is an individual object of that class. And class may have some attributes which are represented by the data about the state of that object. A class is responsible to have some methods to perform actions on that objects, and objects can perform non-traditional actions and can easily be used by more than one program. So we also have an adaptive software development type which is designed to make program development faster and more efficient and focus on adapting the program as it is being written. So it follows an iterative and on or incremental approach, and it follows rapid application development module and extreme programming. So in these methods, we have some agile software development methods which focus on building of small functional program pieces during the project. So whenever you are developing some program, you have to go through certain phases of program development. These phases are element of the program development life cycle. A program development or is usually a process of creating application programs, and the program development life cycle is the process containing 5 phases of program development. So you can have many options to represent these 5 phases. As you have seen in the previous slide, one way to represent one of the phase, which is the coding phase, is to use pseudocode, which uses high level language such as English like statements to outline the logic of the program, or you can use some unified modeling language models to represent some other um, process cycle phases such as design phase and the requirement phase. So these models represent some set of standard notations for creating business models, and they are widely used in object-oriented programs. These include class diagrams, use case diagrams, state diagrams, etc. So these are the common program development lifecycle activities. As you can see, in the first phase you analyze the problem, in the second phase you have some program specification, and on those program specifications you design the program. Upon the design specification, you write the program in programming language, and then you document the code and test and debug the program, and finally you implement the final and updated program. So as the program development lifecycle starts with the inception phase of problem analysis. The problem is considered and the program specifications are developed. Specifications are developed during the program development lifecycle, which are reviewed by the system analyst and the programmers, the person who will code the program. The goal of the analysis phase to understand the functions of the software that it must perform. The documentation, which is the result at the end of this phase, is the program specification, often termed as software requirement specification, or in short SRS. So it includes what your program does, what are the timetables to deliver your program to the end users, what programming languages to be used. So in the second phase, you use this specification or an SRS document to prepare the design of your program. So in the design phase, the program specifications are expanded into a complete design of your new program, and good program design is extremely important for the success of your product. So you can use several program design tools such as structure charts, which depict the overall organization of the program. You can use the flowcharts, which show graphically step by step how a computer program will process the data. Similarly, in the program design phase, it is critical to have good program design principles. So you have to be very specific that all the things that program must do need to be specified at this stage, and there should be only one entry and exit point to every program or sub program. So you should also check there is no infinite loops or other logical errors, and design should be tested to ensure that the logic is correct. So after these considerations, you move to the third phase, which is the program coding, which is the actual implementation of the program in a programming language. So when choosing a programming language, you must consider the suitability of the application, the integration of the application with the other programs, the standards for the company you are developing the program, and the availability of the programmer in the language you are trying to build the program, and also consider the portability if your program is being run on the multiple platforms. So there are different tools to consider and programming languages available to cater the needs of program coding. So whenever you are coding, you have to follow some coding standards, much like the design standard which you have followed in the previous uh, phase. So coding standards are the rules which are designed to standardize the programming, and they make programs more readable and easier to maintain. So the coding standards may include the proper use of comments to identify the programmer and the last modification date. They are useful to explain the variables to be used in the program. Variables are used to store some memory or some data in the memory. So this data is defined for the program and it is used to store the current value of the data items into the program. So the coding standard may also identify the main parts of the program, and you must write the code in a way that it should be reusable code. So you should have some pre-tested error-free code segments that can be used over and over again with minor modification. It will greatly reduce the development time and the speed. It will greatly enhance the speed and accuracy of your development. So comments are also one of the coding standard which you can employ in your program development to enhance the standard of your program development or coding. So comments are usually preceded by some specific symbols, such as in most languages a hash symbol is used for comment, and in some languages a forward slash can be used for comments. So comments just tell you about the type of the file and the code it represents, or some the values about the variables or other processing that your code file can contain. Usually comments on the top of the program should identify the name and the author of the program, date written and last modified date, the purpose of the program, and the variables used in the program. So in the fourth phase, when you have developed the program and you have written that program or translated that program into the coding, the next phase uh, requires you to debug it from the errors and test it so that it can execute in the real environment. So program debugging and testing is the process of ensuring program is free of errors or bugs and works as it is supposed to. So before they can be debugged, coded program need to be translated into the executable code. So whenever you write the program, it is called the source code, which is coded program before it is compiled. So when you compile the code, it is the object code, which is the machine language version of the program. So for that purpose, you need language translators, which are also some kind of program that converts the source code to the machine language. So typically we have three types of translators. The common one for high level languages are the compilers, which are language translators that convert an entire program into machine language before executing it. Some languages have interpreters which translate one line of the code at one time. So we may also have assemblers in some languages which convert the assembly language programs into machine. So debugging can be done at several levels, and at the most basic level, its purpose is to find the initial errors. So at this time you are more concerned about the compiler's errors. If you have some compiler errors, your program will not run smoothly. On the other hand, you may have some syntax errors, which are the errors when the programmer has not followed the rules or the programming language, or the programmer has written something wrong deliberately. You can also come across with runtime errors, which are more difficult to handle because these errors occur at the runtime, and that means when the program is executing. You can also have some logical errors which are which the program will run but produces incorrect results. So you can use the dummy print statements that can help you to locate logic errors and other runtime errors. In the testing phase, it usually occurs after the program appears to be correct and find any additional errors. So you should use some good test data to test your program and test conditions that will occur when the program is implemented. So usually you are most worried to check the condition where you have some statements where you compare two variables from less than or less than equal to or greater than equal to. So you should check for the coding omissions such as this. You can also employ different kind of testing techniques such as alpha testing, which can be done on the product when the product is undelivered to the customers or which are residing inside the organization. Or you can employ the beta testing, which can incorporate outside testers. The end of this phase usually is a completed program package, user manual, description of the software or commands, troubleshooting guides to help with the difficulties. The final phase of the program development lifecycle is the program implementation and maintenance, which requires installing and maintaining the program. And once the system containing the program is up and running, the implementation process is complete and the program maintenance process starts. It is the process of updating software so it continues to be useful, and it usually results in amended program or updated versions of your program. So whenever you encounter a problem, you want to convert this problem into some machine language to solve it. Therefore, you will like to have some kind of mechanism to represent this program into machine language. So programming languages are helpful to achieve such tasks. Usually, a programming language is a set of rules, words, symbols, and codes used to write computer programs. So to write a computer program, you need appropriate software and programming language you will be using. So there are several categories of the programming languages. So at the most basic level, we have low level languages which are difficult to code in, and they are dependent on the machines. So usually machine language is ones and zeros, and you can have some words in low level languages which are often termed as medium level languages, such as assembly language. So it includes some names and other symbols to replace the sum of the ones and zeros in machine language. On the other hand, you have high-level languages which are closer to natural languages such as English, and these are machine independent. That means they can run on various platforms. So these includes third generation languages such as Fortran, Basic, COBOL, or C programming languages, and these programming languages are object-oriented languages such as Visual Basic, C Sharp, Python, or Java. On the other hand, we may have some visual or graphical languages which use graphical interface to create programs. In the advanced terms, we have fourth generation languages which are even closer to the natural languages and easier to work with than the high-level languages. They have a very declarative approach than the procedural approach. So these include the structured query language, which is used with the databases. So let's look at some common programming languages which have been used in the past and currently being employed on or various on a diverse set of devices. So one of the languages is the Fortran, which is high-level programming language used for the mathematical, scientific, and engineering applications because it is very efficient for math, engineering, and scientific application, and it is still used by today for high-performance computing tasks such as weather forecasts. Another common language is the basic language, which is easy to learn, high-level programming language that was developed to be used by the beginning programmers. So another version of the basic is the Visual Basic, which is object-oriented version of the basic, and it uses a visual environment. Another most another one of the most common and most widely used language is the family of C languages such as C, C++, and C Sharp. So C was designed for system programming, and its improved version or object-oriented version of the C is called the C++. Another version which was mm, an enhancement of the C and C++ is C Sharp, which is used for mostly web applications. Objective-C is another language which is used for iPhone and other Apple applications. We have Java programming language, which is another form of high-level object-oriented programming language frequently used for web-based application. Java programs are compiled into bytecode and they can run on any computer that includes Java virtual machine. So it can be used to write Java applets such as to scroll the text on the web pages, games, and calculators. Java is one of the most popular programming languages till today. So let's move towards the final topic of our lecture, which is the discussion of the components which are used to convert a high-level code to a low-level code. And as I have discussed previously, one of the common tool is to use an interpreter and a compiler. A compiler compiles the code from a high-level language to a low-level language before executing it. On the other hand, an interpreter is a program that executes the programming languages or programming code directly without converting it to the machine language code. So interpreters can convert a source code usually on a step-by-step, line-by-line, and unit-by-unit basis into machine code. So interpreted languages are read and then executed directly. There is no compilation stage. On the other hand, a compiler is a separate program that converts the entire source program into machine language before executing it. The machine language version that results from the compiling of the third generation languages is called the object code or the object program. The compiler stores the object code on storage media for execution later. While it is compiling the source code program into object code, the compiler checks the source program for errors. The compiler then produces the program listing that contains the source code and the list of any errors. This listing helps the programmer to make necessary changes to the source code and correct the errors in the program. The examples of languages using compilers are C, C++, C Sharp, COBOL, Fortran, Java, etc. Another component which is used by low-level or medium-level languages, is the assembler. Assembler normally converts an assembly language code into machine language. Assembly language is family of low-level languages for programming computers. It implements a symbolic representation of code. An assembler is a program that takes the basic computer instruction and converts them into pattern of bits, zeros and ones that the computer runs to produce results. Usually they have translators. Translator is a computer program that translates one programming language instruction into another programming language instruction. A computer source code is to be translated into a low-level programming language where native code compilers change it in the machine language for execution. So this slide summarizes the discussion about the components discussed in the previous slides. So at the top level, we have a source program which is usually represented in a high level language or high level program. So to convert a high level language into a low level language, the first thing you need is a translation, and for high level languages we have compilers which convert the whole code into another form of the code. Usually it is an intermediate program represented in assembly language or other low level code. Again you need the translation, and at this stage you will need an assembler because the code is an intermediary code and it is often represented in assembly language. So the assembler converts the code into the object program or the object code in the machine language. Then if you have any external libraries, you have the linker to link the library object code which is required by your program, and then you have the complete object code. Then there is a loader which loads the complete object code into memory for execution. Finally, the execution is presented or executed onto the hardware to produce the results. So that is it about today's lecture, and if you want to read more about the topic, you can go through the recommended books or you can ask me any question. Thank you very much.